Okay, so think about like when you're just messing around with blocks, that building a little tower or something, or even just like picking up a die before you roll it. What's that shape?
A cube,
A cube, right. And that's what we're going to be looking at today in our deep dive, cube numbers.
or perfect cubes as they're sometimes called.
Perfect cubes, right? Okay, so for anyone who maybe hasn't thought about this since like high school math class, what exactly are cube numbers? I mean, the name itself sounds pretty three-dimensional.
Yeah, it really does. Basically, a cube number is what you get when you take a whole number, multiply it by itself, and then multiply it by itself again. You're kind of taking that number and putting it on this like multiplication adventure where it meets itself 3 times over.
A 3 times adventure. I like that. So can you give us a quick example of one of these numbers going on an adventure?
Sure, let's take the number 3. First, you multiply it by itself. 3 times 3 is 9. Then you take that 9 and multiply it by the original 3 again. 9 times 3 is 27, so 27 is a cube number.
Okay, so it's not just 3 times 3, it's 3 times 3 times 3. Right, got it. Now, the name cube numbers, why are they called that?
Yeah, it's not just a random name. It actually ties directly back to the shape of a cube. Like those blanks you were talking about. Remember, a cube has 3 dimensions, right? You've got the length, the width, and the height. And when you calculate a cube number, you're essentially figuring out exactly how many of those little tiny unit cubes you would need to build a bigger solid cube.
Oh, I see. So like if we had the cube number 8, that means we could use exactly 8 of those little blocks to make a bigger cube.
Exactly. If you have a cube that measures 2 units on each side, 2 units long, 2 units wide, and 2 units high, that cube is going to be made up of 8 of those little unit cubes.
Okay, yeah, I can picture that. And I know in math we see all those little superscript numbers, like a tiny little 3 floating above a number. What's that all about?
Oh yeah, that's just math shorthand. Those are exponents. Instead of writing out like this number times itself 3 times, mathematicians, we love our symbols, so we use those little exponents. So like you might see the number 5 with a tiny little 3 at the top right, 5 cubed or 5 to the power of 3. And all that means is 5 times 5 times 5, which we know equals 125.
Yeah, that definitely saves a lot of writing. Can you give us another example, maybe with a slightly bigger number this time?
Absolutely. Let's look at 10 cubed written as 10 with that little 3 at the top. That means 10 times 10 times 10, which gives you 1,000. So 1,000, another perfect cube.
Okay, so learner, for this deep dive, we really want you to grasp this idea of cube numbers and hopefully give you a bunch of different ways to understand it. So how do we actually find these cube numbers? What's the process?
Well, it all goes back to that idea of multiplying a number by itself twice. Let's try it with the number 4, for example. So first step, multiply 4 by itself, 4 times 4, which is 16.
Okay, and then
Then take that 16 and multiply it by the original number, 4, again. So 16 times 4 gives us 64. There you have it. 64 is the cube of 4. The important thing is that the original number appears as a factor in the multiplication 3 times.
so it's not just multiplying by 3, it's multiplying the number by itself 3 separate times.
Exactly. Now, let's actually calculate the cubes of the first few whole numbers just to really solidify this. Starting with 1. What's 1 cubed?
Well, 1 times 1 is just 1, and 1 times 1, again, is still 1. So 1 cubed equals 1.
Easy enough. Now, 2, we did that one before. 2 times 2 times 2 is 8. So 2 cubed equals 8. How about 3 cubed?
That's another one we already did. 3 times 3 is 9, and 9 times 3 is 27. So 3 cubed equals 27. I'm noticing that these numbers are jumping up pretty fast.
They really do, huh? Let's keep going. 4 times 4 is 16, and 16 times 4 is 64. So 4 cubed equals 64. And then 5 times 5 is 25, and 25 times 5 is 125. So 5 cubed equals 125.
Yeah, even from 1 cubed to 5 cubed, the numbers get so much bigger. It's amazing what that triple multiplication does.
Yeah, it makes a huge difference. And this brings us back to those blocks we were visualizing before. We said that 27 is a cube number, right? So picture a cube made out of those little blocks. If it's 3 blocks wide, 3 blocks long, and 3 blocks high, 3 by 3 by 3, that's going to give you exactly 27 blocks in total.
Okay, yeah, so 3 rows of 3, stacked 3 high, perfect cube.
And remember, 8 is a cube number too. So for that one, you could picture 2 by 2 by 2 arrangement of blocks, 2 units in length, 2 in width, and 2 in height. Bit smaller, but still a perfect cube.
So if you wanted to build an even bigger cube, maybe one with sides of 4 units long.
You need 4 times 4 times 4 blocks, which is 64 blocks, to make that solid cube. 64, our cube number, in action.
Wow, those blocks really help to visualize why they're called cube numbers.
Definitely. And this all connects to another important concept, volume. You know, the amount of space a three-dimensional object takes up. And when we're talking about a cube, figuring out the volume is pretty straightforward.
Yeah, it's just length times width times height, right? And with a cube, all those sides are the same length.
Exactly. So if we call the length of one side of the cube s, the volume is just s times s times s, which is s cubed. So the formula for the volume of a cube is literally a cube number.
Oh, wow. I didn't realize they were so directly connected. So if I have a cube with each side measuring 5 centimeters.
The volume would be 5 centimeters times 5 centimeters times 5 centimeters, which equals 125 cubic centimeters. See, there's that cube number, 125, popping up again.
That's really cool how it all ties together. Now, I remember seeing a list of the first few perfect cubes in our notes. Is it actually helpful to know those?
Oh, absolutely. Just like knowing your multiplication facts can speed things up, knowing the first few perfect cube numbers can be super useful, both in math problems and for recognizing patterns in numbers. So the first 12 perfect cube numbers are 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729, 10 cubed is 1,000, 11 cubed is 1,331, and 12 cubed is 1,728.
Wow, it jumps up pretty quickly. From 1 cubed to 10 cubed, you go all the way from 1 to 1,000. I guess that means perfect cubes get a lot less frequent as numbers get bigger.
You got it. The spaces between those perfect cubes get wider and wider. So, you've got 1,000, then you have to go all the way up to 1,331 to hit the next perfect cube. Now, you might be thinking, okay, that's interesting, but do these cube numbers ever actually show up in real life?
Yeah, that's exactly what I was going to ask. Are these just abstract math things, or do they have any real-world use?
Oh, they definitely pop up in the real world, even if you're not always thinking about the math behind them. Take a look at a die. A regular six-sided die, it's a perfect cube, right?
Oh, yeah, it is.
Now, the numbers on the die, those aren't cube numbers themselves, but the shape is. And those ice cube trays people have.
Oh, right. Most of those make cubes, too.
Yeah. Say you had a little ice cube tray with 2 rows, 2 columns, and it made 2 layers of ice cubes. That would be 2 times 2 times 2, which is 8, another cube number.
Right. 8 ice cubes. And what about those building blocks kids play with? Some of those are cubes, too.
Exactly. And if a kid built a bigger cube that was 3 blocks wide, 3 blocks long, and 3 blocks high, that would be 3 times 3, or 27 blocks, another cube number in action.
And I've even seen those little cube-shaped gift boxes.
Those two. And, you might not be calculating the volume every time you see one, but the fact that it's a cube means the space inside it, the volume, is directly related to the cube of one of its size. So that cube shape and the math behind it is actually all around us.
Okay, so it's not just some weird math thing. It pops up all over. And our notes mentioned a few interesting facts about cube numbers. What can you tell us about those?
Sure. Here's a cool pattern. If you cube any even number, the result will always be an even number.
Really?
Yeah. Take 2 cubed, 2 times 2 times 2 is 8, or 4 cubed, 4 times 4 times 4 is 64. Why do you think that happens?
Well, an even number can always be divided by 2, right? So even if you multiply it by itself a bunch of times, you're still going to have that 2 in there somewhere.
Exactly. That factor of 2 guarantees you'll end up with an even number when you cube it. Now, what about odd numbers?
Well, following that logic, if you cube an odd number, you should always get an odd number, right? Since odd numbers don't have that 2 as a factor.
Exactly. Like 1 cubed is 1, 3 cubed is 27. Multiply an odd number by itself as many times as you like, it's still going to be odd. And another thing that's interesting about cube numbers, and we talked about this a bit before, is how quickly they grow.
Oh, yeah, they do get huge fast. Like 5 cubed is 125, but 6 cubed is already 216. And the bigger the numbers get, the bigger the jumps between the cubes.
Yeah, they really take off. It's a testament to how powerful that repeated multiplication is. Okay, so we've covered a lot about cube numbers, but I'm sure our learner might still have some questions. And luckily, our notes had a little FAQ section to address some of the things people often get confused about. What are some of those common questions?
Well, a lot of people seem to have trouble understanding the difference between cube numbers and square numbers. Can we go over that one more time?
Sure, no problem. So a square number is just a number multiplied by itself once, or raised to the power of 2, like 3 times 3 equals 9. So 9 is a square number. But a cube number, like we've been talking about, is when you multiply a number by itself twice and raise it to the power of 3. So 3 times 3 times 3 equals 27. 27 is a cube number. The difference is all in how many times you're multiplying that original number by itself.
Okay, that makes it clear. Another question that comes up a lot is 0 a cube number?
Well, let's think about it. 0 times 0 is 0, right? And then 0 times 0 again is still 0. So, yeah, it fits the definition.
So 0 cubed equals 0, making it a cube number. And what about negative numbers? Can you have negative cube numbers?
That's a good question. So, remember when you multiply a negative number by a negative number, you get a positive number. But then, if you multiply that positive number by another negative number, you end up back in negative territory. So yes, you can definitely have negative cube numbers, like -2 times -2 is +4, and then 4 times -2 brings you back to -8. So -8 is a cube number.
Oh, right, that third multiplication flips the sign back. Okay, one more term that seems to confuse people is cube root. What does that mean exactly?
Basically, finding a cube number is like asking, what do I get when I multiply this number by itself 3 times? Finding a cube root is the opposite. It's like asking, what number multiplied by itself 3 times gives me this cube number? So if we know that 3 times 3 times 3 equals 27, then the cube root of 27 is 3.
Right, and there's a special symbol for cube root too, right?
Yeah, it's that radical symbol with a little 3 tucked into the check mark. So the cube root of 27 is written as that symbol, then 27, and it all equals 3. And then one last misconception people often have is thinking that every big number has to be a cube number. What do you think?
I'm going to say no. Just because a number is big doesn't mean it's the result of cubing some whole number.
Yeah, you're right. A perfect cube number is very specific. It has to be the exact result of multiplying a whole number by itself 3 times. So like 10. It's bigger than some of those first few cube numbers, but it's actually stuck between 2 cubed, which is 8, and 3 cubed, which is 27. There's no whole number you can cube to get exactly 10.
Oh, okay, I see. So perfect cubes are actually pretty special, and they get more and more rare as you keep counting up. Well, listener, I hope this deep dive into cube numbers has been helpful. We started with that basic idea of a number multiplied by itself 3 times. Then we talked about how it relates to the shape of a cube and how it connects to the concept of volume. We went over the first few perfect cube numbers, saw how they pop up in everyday objects, and even uncovered some cool patterns about even and odd numbers. And of course, we tackled some of the questions that people often have about this concept.
And hopefully you've come away with a solid understanding of what cube numbers are all about, why they're called that, and how they fit into both the world of math and the world around us.
So next time you're going about your day, maybe you'll spot some cubes and think about that idea of cubing things.
It really is all around us. And to leave you with a little something to ponder, now that you've learned about cube numbers, what other mathematical ideas might be hiding in plain sight, connected to the shapes and objects we see every day? It's amazing how often these seemingly abstract math concepts actually have real-world connections.